Alright, class. So another fundamental topics in machine design. Okay. So this is 10-walled cylinder. So 10-walled pressure vessel or 10-walled cylinder is one whose plate thickness is small compared to the diameter of the vessel. So the ratio of T over the inside diameter is equals to or less than zero point 0.1. Okay, so here is the illustration of the pressure vessel. So of course, this is cut in order to identify the stress acting, of course, at the plate of the cylinder. Okay, so actually, class, this is purely tension. So this is an application of pure tensile force. So you will notice here that we have the most common failure is of course the circumferential stress of the pressure vessel, and we have here the longitudinal stress. Okay, so the derivation, of course, of the formula uh, in pressure vessel is quite easy. Okay, so we have here for circumferential tensile stress. So the fluid force acting on the longitudinal section of unit length is equal to PD, of course. So that is the resisting, of course, area. Okay, so P or P multiplied by the diameter. Okay, so from the definition of pressure is equals to F over area. Okay, so or for equilibrium forces may be equated to be the resisting force equal to 2T multiplied, of course, by the stress. So where the sigma T represents the circumferential or Hooke stress, or sometimes called tangential stress. So the derived equation here, of course, is PD over 2T. So how this formula was derived? So of course, you just equate the tensile force acting, of course, at the circumferential section of the pressure vessel equal to the force acting due to the pressure of the vessel. Okay, so by just equating the two, the derived equation now is for the circumferential stress is PD over 2T. Okay, so for longitudinal stress, so the fluid force acting, of course, on a ring section is equal to the 1 over 4 phi multiplied by di square p. And the equilibrium forces may be equated to the resisting force pi dt. Okay. So represents the longitudinal stress. So the equation is only equals to PD over 40 instead of PD over 2T for circumferential stress. Okay? So this is very easy. So we have also the joint efficiency or the relative strength. So joint strength is the ratio of minimum strength of joint to the strength of solid plate. Okay? So minimum strength of the joint divided by the strength of solid plate. Or simply, for circumferential tensile stress, sigma T is equals to PD over 2T multiplied by this joint efficiency. And for longitudinal stress, sigma L equals to PD over 4TN. Okay? So that is easy. So we have now here an example of this thin-walled cylinder. So a water reservoir of 24 meters high and 12 meters diameter is to be completely filled with water. Find the minimum thickness of the reservoir plating if the tensile stress is limited to 50 megapascal. Okay, so we have here the given the hydrostatic pressure. P is equals to gamma multiplied by the heat H or the height of the fluid, or simply the pressure is equals to 0.23544 megapascal or Newton per millimeter square. Okay. So for the stress now, or the circumferential stress, that's PD over 2T. Okay. So the thickness now is equivalent to 28.25 millimeter. Okay. So it's quite thick. Okay. So That's our class. Thank you very much. Okay? So, just wait for another presentation for this topic. Of course, for more example and solve problems. Okay? Thank you very much.